How are you guys? Welcome back to my channel. We're still under the properties of fluid mechanics and 5. Okay guys, do not forget to subscribe and like this channel. Please subscribe, do not forget, subscribe there. Okay, today let us deal with this question. I've taken it from, this is usually an example. It is an example from your textbook, right? So I've just depicted this structure here. It's an example. It is page what? It's page 6. You'll see when you're using that small book, the small textbook, where okay. I want you guys to understand this. You see, the example says a shaft with a diameter of, they've given us a diameter of 74.9 millimeter rotates. Because it's rotating, it's falling under what? It's angular motion. When we're dealing with objects that are rotating, usually take us back to angular motion. We call them angular motion, right? Angular motion. You remember it from N4. You remember your angular motion, engineering science, and for you return back to angular motion. We're not dealing with things that are rotating. We know shaft is rotating once. Note this, in a bearing, with a diameter 75.03 millimeter and a length of 75 millimeter. You see, this bearing has a diameter and then this base length. Here is the bearing. I've illustrated here, I depicted it, I've drawn here. This is the bearing with a length of 75. These are bearings with a length of 75 here. This is the bearing with internal diameter. I've wrote here is this diameter there. And you see from here till there, from here, because you're looking the internal diameter usually is this part, this diameter of the, if you have a bearing, yeah, we take this, yeah, this diameter, right here, this diameter here, it's a bearing. Then there's a shaft. Here is the shaft here. We've depicted that shaft with a diameter of 74.9 millimeters. This is the shaft. It's rotating on the bearing. Okay, and the annular space between the shaft. You see the annular space between the shaft and the bearing here. This space here. This space here to here to the bearing. You understand? Is filled with an oil. That is why I did like this. Is filled. This space is filled with oil. It is filled with oil. See, it is filled with oil. This is an oil. Alright. It's filled with oil. And then remember, this thickness will form a thickness of layer of oil. This will be what? This distance from the shaft to the bearing. This one, the smallest distance, supposed to become what? A thickness, which is what is clearance. This will be a clearance. Remember, a thickness of layer of oil is equal to what? To clearance. This is what is a thickness. This oil will form what? A clearance. We have a clearance here. Fine. We have, okay, it's filled with oil, has a coefficient of viscosity of 0.909 poise. Right, we have the viscosity. Then the question says determine the power used to overcome viscosity resistance in the bearing of, they've given us, this is like its revolution, the speed, they've given us speed, revs per minute, they've given us in rev per minute, right? Good. Now they say determine power. I've write this formula here. We know power. You are under angular motion. Remember, this is what? It's angular motion. When it's angular motion, remember, if it's a linear motion, power is supposed to be equal to what? Force multiplied by what? By velocity, right? But now, remember, this is a rotating motion. Since it's a rotating motion, we're supposed to calculate power will be torque multiplied by angular velocity. Why? This is a linear velocity. This is the angular velocity. This one it's linear velocity. Why we're using this is because it's a shaft. It's a rotating shaft. Shaft is rotating. Then we will apply angular motion. Right? Yeah, this is important to understand that. Okay, so now they want us to determine power to overcome the viscosity resistance. Okay, we know, you can come and say we know that they want power, right? And we know that if they want power is supposed to be calculated by torque multiplied by angular acceleration. We don't have torque, we don't have angular acceleration. If we can get these two things, we are done. If we can get torque and get angular, then we will be able to calculate what power. So I want us to come in. We know that the force, we know that torque is equal to force, right, multiplied by radius, whereby radius is equal to diameter over 2. You can substitute this radius with what? With diameter over 2, right? Let us calculate what we want the torque. But what about the force? We know also a force is given by area, coefficient of friction, multiplied by velocity, multiplied by clearance. This is a force, right? So that we're able to calculate the torque. When we have force, we calculate the torque, right? After calculating the torque, we substitute there to the power formula. Then we have angular. We know that angular acceleration is 2 pi n, right? If you can get this information, we're done with our power. Now, do we have velocity? No. Do we have this? Yes. Do we have area? We don't have area. Okay, I can say area. I can simply write area. It's equal to pi multiplied by diameter multiplied by length. And then do not forget, I've explained this. This will be pi. The diameter, remember, will be a diameter of what? Of the shaft. This is the diameter of the shaft. Diameter of the shaft will be the diameter of the shaft, right? Which is, we know the diameter of the shaft is this one, 7,499 divided by 1,000, which is will give us 0,0749, right? Multiply the length. The length that you're supposed to calculate, it's a length, is not the length of the shaft. This is supposed not, it's a length, it's a contact area. This will be the length of contact area. Where the bearing will be touching, it's here. This contact, the length of this contact, which is the length of the bearing, is not the length of the shaft. But remember, when we're dealing with the piston, if it's a piston, it's supposed to be a length of the piston, diameter of the piston, if we're dealing with the piston, right? But now we're dealing with the shaft. When we're dealing with the shaft, yes, it will be a diameter of the shaft, but not the length of the shaft. The contact area that will be kept, and maybe it's a what, it will be a bearing or whatever that will be. It's either it's a bearing or will be its parts, it will depend, will be the length of what? Of the bearing. This is the length of the what? Of the bearing. Always of the bearing, not of the shaft. You understand that? Fine. We have the length of the bearing, say 75 millimeter, divide by 1,000. When you divide by 1,000, you will get that this is 0,075, right? Then you multiply. When you multiply, you're supposed to get that your area is 0,1765 meter squared, right? Meter squared. We have an area. What about the velocity? What about the velocity? Yes, velocity if you know this formula, pi dn velocity will be pi d n over 60. This is the diameter of what must be the diameter of the shaft, guys. Diameter of the shaft, that one. Diameter of the shaft. Not put the diameter of the bearing, will be wrong. Of the shaft. This is the diameter of the shaft. This is the one that it's moving here. The pi diameter of the shaft is 0.0749 multiplied by, and our n is there. We have given us where it is. Here it is. It's 1,400 revolves per minute, which is will divide by 60 to convert this to be inverse. Divide by 60 because it's in minutes, right? It's in rev per minute. Then when you calculate, so that our velocity will be in meters per second, when you calculate this, you're supposed to get that your velocity is 5,49 meters per second. We have area, we've calculated it. We have this, we have this. Now we don't have what? Clearance. Let us calculate the clearance. This will be a diameter minus d over 2. This must be what of the bearing. This what must be what of the shaft. Right, bearing must be of the bearing of the shaft divided by 2. If it's a piston and cylinder, this will be of the cylinder of the piston divided by 2. Those diameter here. Diameter of the shaft we have, diameter of the bearing we have. This when we divide, we have that ones. We know that the diameter of that thing is supposed to calculate it. The supposed to have our clearance, right? So we can calculate the clearance. Substitute this diameter of the bearing diameter is this one, right? You can write it as it is, then you'll divide your final. You can say 75,03 minus 74,9 over 2. Remember this, it's in millimeters, but your answer, you're supposed to divide it by what? The final answer, you will divide it by what? By 1,000, right? We divide it by 1,000. Let me punch it here. I want the clearance is 75,03 minus 74,9 divided by 2. I get this, right? 0,065. 0,065. This is 0,065 with what? Millimeter. But we want it to be what? In meters. Remember, it's supposed to be in meters. When it's in meters, this you divide it by 1,000, or you can simply write this as times 10 to the minus 3 meter. Yeah, we are dividing when you did that. Just you can write it in scientific notation form if you understand it. Now we have this clearance, right? Since we have a clearance, we have a clearance now. We can calculate what? Force. You can calculate the force, right? Let us calculate the force. Just calculate the force. Then force will be equal to what? Will be equal to the area. Do we have what its area? Let's take us here. Its area will be 0,01765 multiplied by coefficient of friction here. They've given us where it is here of viscosity 0,096, right? 0,096. 0.960. They've given it there. Then we substitute it 0.096. We multiply by the velocity. We have calculated here, it's 5.49 divided by clearance. Here it's our clearance, which is 0.0665 multiplied by 10 to the minus 3. Right, this is what supposed to be our force, this one. But let me erase here actually. Allow me to erase this. Let me erase this side. Right, let me erase this side. I hope you have captured all of this information. Let me erase this side. Let me erase here. Let me erase here. Right. Let me just write. Let me just say torque. I want us to write. Let us just say power is equal to torque multiplied by power is equal to, let me just write here, power is equal to torque multiplied by angular. Right, then torque is force. Here we have the force there. Here it's our force, which is 0.01765 times 0.096 times 5.49 over 0.065 times 10 to the minus 3. Remember, it's torque. We multiply by what? Remember, torque supposed to be force multiplied by d over 2, which is the radius. We take the diameter here. This is diameter. We divide it by, here is the diameter here. Then will be 0.0749 divided by 2. Divide that diameter by 2. Let's divide our diameter, then we multiply by this angular, which is the angular acceleration is 2 pi n, right? It's 2 pi n. Right, it's 2 pi n. Then you can write 2 pi divided by 1000. What? Divided by, what is that? Is 1000. Oh no, it's not 1000. No, it is 14,000, right? Divided by 14,000. Yes, it's 1,400. Yeah, 1,400 multiplied by 1,400. Sorry for that. Then when you punch this on your calculator, you're supposed to get that the power supposed to be 78575 watts. It's measured in watts. Right, this is our power. You understand that power is torque multiplied by angular velocity. Yeah, we know that torque is force multiplied by radius. We multiply by angular, then we get the power. Understand? So thank you guys for your time, and thank you for watching this video. Please do not forget to subscribe so that will help me to grow this video, and also you'll be notified when I post a new video. Thank you guys. Do not forget to also share the videos to your colleagues.